I want to skip down to yeah, I'm going to skip this. I want to talk about this, solving equations with roots and radicals and powers. Okay. The whole reason that we're even talking about this stuff is so we can use it to our advantage in solving equations. Now I want you to think back to chapter 5 for a second. Chapter 5 is the model for what we're doing now. In chapter 5, remember that we had a variety of different kinds of quadratic equations to solve. The easiest ones, by far, were the ones where we were able to point to a single x and isolate it, right? And you guys got very good at that. Remember, if I gave you one like this, what if I said, make the hardest one I could? Okay. Now that's one where we would have, and you still would say, what's the technique I would use to solve that? Yeah, I'd isolate by reversing order of operations, right? So to solve for x, in order, what are the steps I would go through? First I would add 4, then I would divide by 2, then I would square root, then I would
subtract 3.
Right, exactly. Okay, and so the key there was we had that step we were able to square root both sides, right? And if we did the math, we just got 2 times the quantity x plus 3 squared equals what? 15. Divide by 2. And I got 7.5. Let's just do that. Let's get rid of that too. And then we square root, right? So we got x plus 3 equals, what am I missing?
Plus or minus.
Plus or minus. Okay. Now that's going to come up with us again today. Whenever, here's the trick. I'll go over it again in a second. But whenever you're solving an equation by taking roots of both sides, if you're taking an even root, in other words, if you're undoing an even power, that's when you have to have the plus or minus. If it's odd, you don't need it. For example, if we were taking a cube root of both sides, I would not have to put that there. Or a fifth root of both sides, that'd be fine. But if I'm taking a square root, which is a second root, or a fourth root, or a 10th root, or a 100th root, or something like that, if it's an even number, then I must have the plus or minus there. Okay? That's the only thing you got to remember about that. And then last step would have just been to subtract 3 from both sides. And so we just would have had negative 3 plus or minus square root of 7.5 and been done, right? Well, the whole point of adding this stuff today, really, is to allow us to do stuff like that for problems that aren't just quadratic. Like in this case, we've got a cubic equation, right? Now, what we've been doing in Chapter 6 is we've been factoring this by a difference of cubes, which is a pain. We don't want to have to do that. We can just point to the x and isolate it by taking a root of both sides. Only the root that we take this time is a cube root, but it still works. So if I've got x cubed equals 64, then x just equals the cube root of 64. Which is the same thing if I'd rather write it this way as 64 to the 1/3. What is that number? 4. And there is no plus or minus there because 3 is odd. Okay? Now what about, okay, so there's one. Let's try another one. Oops. Yeah, this guy. Okay, what about this one? Now, what do you suppose? Now, I think what we just did in that last example, we had x cubed equals negative 64. So to undo that, we took a cube root, didn't we? Right? Now, think in terms of exponents why we did that. If I take a cube root, that's the same as a 1/3 power, right? Well, why do you suppose we do that? What is x to the third to the 1/3? If I take a power to a power, what's that do to the exponents? Yeah, I multiply them, right? And 1/3 times 3 is 1. So that's really what we're doing when we take a root. To undo an equation, we're just making the exponent equal to 1, right? By undoing the exponent. So I get x to the 1 equals negative 64 to the 1/3, which is negative 4, right? So what would I do in a situation like this then, if I employ that same logic? If I want to just undo x to the 4/5, what would I have to multiply the fraction 4/5 by? The reciprocal. Sure, okay. So let's do that. So we've got our x to the 4/5 equals negative 625. So if I take both sides to the 5/4, okay, then that's going to cancel those, right? And I just get x. But now think about this. We got to be careful. The denominator tells us what kind of root that is, right? That's a 4th root, isn't it? An even root. Can I take an even root of a negative number? No, I can't, right? Square roots were just our first example of that. We always said we can't take a square root of a negative number. Well, we can. We get i's, but we don't get real answers, right? That's going to happen for any kind of even root. That goes with that whole plus or minus thing. They go hand in hand. So what's my answer here?
0.
No real answer, right? It's not 0. There is no, on Moodle it's going to say if there's no real answer, enter 999. So this would be a 999 case because we've got an even root of a negative number. Okay, so it's non-real. Make sense? Okay, now otherwise, all I would have done is just, what if this had been a positive 625? Then I could have just taken 625 in my calculator to the 5/4 power, and it would give me an answer. Okay, I can even do that in my head, really, because what I can do is I can break it into two pieces. If that had been a positive 625, I could take the 4th root first, right? Take care of the denominator, and then just take that to the 5th power, right? So the 4th root of 625 would be 5. To the 5th would be something big. I don't know what that is. Something big. We can figure it out, but how about we don't? 30 something. 30,000 something. I don't know. But anyway, you get the idea. But your calculator can do that for you. You don't have to even worry about doing that part. You would just feed that in there. But that one's not going to give you an answer. Okay, so this one would have been 999. Okay. What about let's try this guy. Okay, now this is one of those situations like we did in chapter 5. How am I going to solve this one? Can I point to a single x? Yeah. Should be able to isolate it. With our new, this new extension of what we know, we should be able to isolate it. Now, what are the steps I'd go through in order to get that x by itself?
Get rid of this.
I can't add 12 yet because it's inside the... How do I undo that power?
The reciprocal.
So, yeah, okay, good. Take both sides to the reciprocal power, to the 3/2 power. Okay, so let's try that. So I get x, really that's just x minus 12, isn't it? Equals 36 to the 3/2. Okay, now what number is that? Well, what's 36 to the 1/2? That's a square root. 6 cubed, 216. So x minus 12 equals 216. Add 12, right? What? That's right, isn't it? 216?
Yeah. 248.
Okay. Well, let's check it. Okay, this one was a bonus because I meant it to be really hard, but it's not that bad. Yeah, before, and don't just jump into it. Take a second like we do in class and just kind of rehearse. What are the steps I'm going to go through to isolate the x? Okay, so now think about that. In order, what's the first thing I'm going to do to get that? Okay, yeah, subtract 15. Good. So if I subtract 15, it gets rid of that part, right? Then what? Divide by 4. Okay, so cube both sides, right? Okay.
Subtract 1.
Subtract 1.
Divide by 3.
Divide by 3. We got it. So it took a few steps, but that's how we would do it. Okay. All right. Good. Now there's one little bit there that I haven't really mentioned that you'll talk more about next year. Oops. You'll talk more about next year, and that is I'll just give you a little hint of that for now. When you solve a problem like this, when you take both sides to a power, sometimes you introduce extra solutions. And so technically what you need to do is go through and check the solutions that you get and make sure they work in the original equation. We call those extraneous solutions, but it's something that you're going to in the future have to be aware of. When you take both sides to a power, check for extraneous, which are like extra non-functioning solutions. And where you go to do that is just right up there. Okay. Let's look at another one like that. We're about done. Okay, what about these radical equations now? These are, let's do that one first. Solving radical equations. Once again, it seems like it ought to be really hard, and it's just not. If we just think of the stuff we just did, the way you do these is just obvious. What would you suppose that you would do to solve this equation? Keeping in mind that probably I got to get rid of that radical, right? What do you think I could do there? To solve that, I got to get rid of that radical, right? Because I've got an x inside the radical and an x outside of the radical, and that's a mess. They don't really get it, right? Square it, yeah. All we have to do is just get the radical by itself, which it already is, on one side of the equation, and then, in this case, I'd square both sides to undo the square root, right? So if I square both sides, what's going to happen to this side? What is the square root of 3 minus x squared? 3 minus x. That undoes the radical. On this side over here, I get the quantity x minus 1 squared. Now that's starting to look normal. That just looks like a quadratic equation in a little bit, right? When I square this out and add up the like terms. On this side, I'm just going to get x squared minus 2x plus 1 if I FOIL that out. And over here, we get our 3 minus x. What would I do to solve that?
Add like terms.
Add like terms. Okay, so I'm going to push everything to one side, right? Set it equal to 0. So add x and subtract 3 from both sides. So then I'm going to get my x squared. How many x's am I going to get over here? Let's see, negative x, if I add x. And if I subtract 3, I get minus 2. And that whole thing is equal to 0 now, which I'll put on the right. How about it? That's an easy one. How can I solve that? I mean, I could quadratic formula it, but does it factor? What are my magic numbers here? Yeah, magic numbers that multiply to -2, add to -1. And so I get answers x equals 2 or x equals -1, right? But remember, we got to check because we did end up squaring both sides. We got to go back up to the original equation and check those out and see if they both work. So what I have, 2 and -1. So let's try and see what happens. If I put 2 in there, I get the square root of 3 minus 2 equals 2 minus 1. True or false?
True.
True. Isn't that just 1 equals 1? Right? So that one is true. So 2 works. Let's try -1. If I put in -1, I get the square root of 3 minus -1 equals -1 minus 1. Is that going to work?
No.
We're going to get the square root of 4 is 2. So this side gives me 2. This side gives me -2. Ah, those are not equal. So that one was extraneous. That one we can get rid of. But the 2 worked. Okay? Right? Okay, and then we won't have time to do this last one, but what would we do on that guy if it's a cube root?
Same thing.
Yeah, cube both sides, right? If I cubed both sides there, I would get 12x minus 28 equals, on this side, if I cubed it out, just trust me on this one, you would get x cubed minus 3x squared plus 3x minus 1. And if I combined all those like terms, x cubed minus 3x squared, if I subtract 12x, I get minus 9x, add 28, I get plus 27. Now, we won't have time to finish it, but that's got 4 terms in it. How would I solve that quadratic? Say it again. Grouping, exactly. I could factor that by grouping. Okay. That's pretty good. Is that I see? Aren't you kind of glad when that just took what you knew, and with like just a little bit of extra material, it takes you up to here. So we had to get through that. I don't know if I can do it.